right, what's going on, you guys? Today we're picking up where we left off on our lab. I believe the last thing we did was set up our SVIs, and yeah, I believe that's the last thing we did. So we're gonna kind of just pick up where we left off and finish up this lab. Today we'll be setting up the virtual IP addresses for both sets of distribution switches. And we'll also be configuring the links, these routed links between the core switches and the distribution switches, and also be making the connection between Office A and Office B, so our PCs can receive the IP addresses via DHCP, and these PCs being able to access the DNS server. So let's just go ahead and get started. So let me make sure everything is still happy, brief. Everything still looks good. So let's go ahead and set up the virtual IP address. So we'll be doing that for each VLAN, and the virtual IP address will be the IP addresses that our PCs will use as their default gateways. So let's go back to VLAN 10. We're gonna do the standby. IP standby maybe, or it's just standby. I think it's standby. Okay, standby IP, and for VLAN 10 it would be in.1, and we're also gonna enable preempt. Preempt is basically so if, let's say, D switch A1 goes down, um, D switch A2 will be able to take over and fill its place as the main router. I believe that's all preemption does. It overthrows the lower priority active router. So yeah. And if D switch A1 comes back online, if preempt is enabled, D switch A1 will be able to take back the role of the active router. We're also going to set the priority to 110. The standby IP. 110. So okay, so I think I messed up. Let me do so IP standby brief. Yeah. Okay, we're good. We're good. Let me just check the running config. Oh, this is standby 0. I didn't specify a specific number, so it just gave it the number of 0. So that is it for VLAN 10. Yeah, we're going to go ahead and do the same thing for VLAN 20, 30, 40, and 99. Standby IP 192.168.20.1. Perfect. Oh no, we got to go back and change that. The reason we have to change it is because we have to specify a number after standby, or else it'll be grouped with the same standby configurations as VLAN 10. But no standby IP. Told you guys we're doing this raw and uncut together, so you're gonna see basically all the mistakes that I make. No standby. Okay, let me VLAN 20. No standby IP. Let's just put no standby. I just want to clear the configs off that. This work, perfect. 20.1. Let's see the running config to make sure we're good before we continue. Okay, now we can make sure we do this correctly. Standby 20 E 192.168.20.1. I'm gonna go ahead and set it to preempt and also make it the active router. I did it again. Standby 20 preempt and also standby 20 priority 110. We're making this router the active router for all VLANs. Now we're gonna go ahead and do it for VLAN 30. Standby 30 IP 192.168.30.1. Here, we'll do it like this so I don't mess up again. Preempt and make it the active router. And we'll go to VLAN 40. Standby 40 P 192.168.40.1. Set the priority to 110 and enable preemption, but not least VLAN 99, 192.168.99.1. Mm, okay. Let me look at the running config. What did I do wrong? Oh, we're still on VLAN 40. That's why. So let me be this and no, and put this under the right VLAN. All right, 110, preempt. And I think that's it for this switch. Let me just check the running configuration one more time, make sure we're good, and we can move on. VLAN 10, correct, correct. 20, correct, 30, 40, and 99. Everything looks good. And we're gonna go ahead and do the same thing on the distribution switch A2. Standby. And the thing is with the redundancy, is it HSRP or whatever it's called? The standby numbers have to match for the routers to peer with each other. So we got to match it up to what the standby number was on D switch A1. So I believe it was 068 and dot one. 92168.10.1. And also, so on this router, we do not have to change the priority because we want this one to be the active router. So we'll leave this one at the default of 100. So the higher the priority, whoever has the higher priority will take over as the active router. So that is it for VLAN 10. Now we're in VLAN 20, so we're going to do the same thing. 6A.20.1 and just enable preemption, and that will be it. Now VLAN 30. 30.1 and VLAN 40. 40.1 preempt. And as you can see, we're getting these messages as our switches go through the learning process of hearing with the other switch. Is that everything? Interview. No. Stand by. 29. IP. 192.168.29.1. A. Check the running config. Make sure everything is good. 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 A. So to make sure everything is geared and paired properly, we're gonna check with the show standby brief command. And as you can see, that this switch right here is in the state of standby. So everything is configured properly. If we go on this side, we should see that. Oh, standby brief. This side is active. So the purpose of that was so when our PCs, when they receive their DHCP addresses, and let's say they want to send information to a separate network. So instead of pinging .2 or .3 for their default gate, excuse me, not pinging, instead of sending their traffic to .2 or .3, they will send their traffic, their default gateway will be set to .1. And since D switch A1 is the active router, the messages will be forwarded to this switch right here. Let's say for some reason the network fails and this switch got shut down. So in the unfortunate situation, if that happens, this switch will be able to take over and still forward the traffic outside of the network. So that is pretty much the main point of having that redundancy. So yeah, we're gonna go ahead and just do the same thing for what you call it for Office B. We're gonna start. We'll switch it up. We'll make B2. Excuse me. We'll make B2 the active router or in Office B. So we will do raise VLAN 10 standby 0 IP 12169 this time 10.1 standby 0 preempt. We will configure the priority on the other side and we will leave this side as the default. Standby, oh, we need to go. Okay, we're good. Standby 20.69.20.1. Gotta retype it. 20 preempt 30. 1, 40. 40, 40.1. Preamp, preemption. Last but not least, VLAN 99, standby 99, IP 192, 99. And set it to preempt. Just check the running config before we move on. Make sure everything is looking good. Boom, 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 boom. And VLAN 99. Good. Uh, we will do distribution switch B2. Standby 0, IP 192.168.1.n.1. Preempt. And also the priority of 110, so it becomes the active router. And we continue. Preempt. Ready. VIP. 30.1. Preempt. 30. 110. With the VLAN 40. As you guys can see, I'm trying to push through this now. I'm ready to get done with this step. 40.1. Preempt. 30. Keep forgetting to put the number. There we go. Now these 99. Preempt. 40, 110. And that should be it. As you can see, the notifications are coming in that this router is the active router. But we will check the standby brief just to make sure everything is correctly. As you guys can see, I'm the type to kind of check as I go and make sure my configurations are correct. Because if you don't check and you wait till the end, it's easy to forget what may be wrong. So that's kind of the benefit of checking as you go. Because then if you mess up, you can find out right away and you're not rambling through all your configurations later trying to figure out what the actual issue is. All right, so as you guys can see, everything is correct. And by okay, perfect. Okay, boom. We have our redundancy set up in our on our distribution layer. Now it's time to let's go ahead and set up our DHCP pools before we start making connections over from office to office. So we want to DNS, going to turn that on. Oh, can you do excluded addresses in the actual server? Not sure. Or okay, so NA is going to be for Office A. I'm so slow. This needs to be DHCP. I knew like that looked it weird. Okay, so this will be our first pool. And we'll say this is for VLAN 10. The default gateway will be 168.192.168.n. The DNS server will be 192.168.99.50. And the start IP address will be 168N, and it will start at N. Base, right. Not gonna set up a WLC. We're not gonna do any wireless in this lab. And that is pool one. We're gonna go ahead and save that. And we want to do another pool. And this will be pool 20A for VLAN 20 in Office A. And all we have to do is switch this, and be it. Now we have pool 20A. Is that correct? 20, perfect. We're gonna do the same thing for 30A. 30. I'm sorry, guys. If I'm moving a little slow. I want to make any errors. Start IP address C. I know I needed to change that. And I add that. Make sure did I? It's perfect. Pool 40A. 4. Keep that. Change that. And we will add that. Last but not least, 99, 99, 99. Default gateway. Add. Okay, that's it. So make sure everything looks good. 28, boom. VLAN 10, boom. Perfect. Right now we'll do for this B and B. We gotta change this to 99. I'm at 169. DNS server still is in the same place, 169 for that. And Are you kidding me? My packet tracer just crashed. Okay, so we're back recording. The packet tracer actually crashed on me. So I'm just making sure I save everything as I go so I don't have to re-enter all my configurations. So picking back up where we left off, I'm just adding the DHCP pools so our end devices can receive IP addresses. So yeah, we're doing that now. I'm wrapping up. We're finishing up the pools in Office B, and we will be on our way. I'm just double checking, making sure I'm entering in everything correctly. As you all may know, one misinput can mess up everything. So I'm just really taking my time so I don't have to go back and fix anything. Yeah, when it comes to networking, you have to pay attention to details. That is a must, which I don't mind. Just have to take your time. So I think all the pools are correct. And we will continue. Let me just make sure my audio is going. And I think we are good. So we have our DHCP pools configured here. And we'll also set up our DNS server. And we'll just create, I don't know, google.com address 8.8.8.8. We're going to add that. So we at least have one DNS record. So let's go ahead and create these layer 3 links or layer 3 connections, I might say. We're going to go with the 10.0.0 IP address subnet. And we're going to do 10.0.1.0, 10.0.1.0. So that's 24 on this side. Up here, this can be 10.0.2.0, so that's 24. Sorry, guys, I do not feel like doing subnetting or VLSM. So everybody's getting a 24 block today. There we go. 10.0.4.0. And that should be it for our layer 4 connections so far. All right. And what I want to do is have OSPF running separately on each separate network. I don't want them peering or having one big, I don't want them sharing routes to one another. I don't think it's necessary. I just want to have a default route at our core layers to each separate office, and that's how they'll be able to communicate. So before we do, well, first we have to set up these interfaces. So this is, oh wow, we got an fast Ethernet connection, fast Ethernet, and gig. Can we, that's gonna bother me. Can we, yeah, let's have gigabit on both sides. So I'm gonna move these out the way. And this will be .2, .2, .1, and .1. Oh, this is a lot. We'll just have one right here, then one over there for the time being. 2 and 2. Sorry, guys. Sorry if this is a little hard to see. It's a little confusing. So just bear with me. Okay, what I'm going to do is I'm going to scoot these up a little further so we have more room. You can see a little better. There we go. .2. Okay, hopefully that is a little better. So the first thing we need to do is configure our, what you call it, distribution layer switch, and change these. Oh my God, I keep forgetting what it was. 106.06 interface G0106. First thing we got to do is change it into a routed port. All switch interfaces by default are layer 2, and the command no switch port turns a layer 2 interface into a layer 3. So after doing that, now we can assign an IP address to it like a regular layer 3 interface that you would see on like a router or something. 0.0.0, excuse me, 2, 255.255.255.0. That is it. And we'll do the same up here. What is this? G01. First enable IP routing. I don't know if we did it yet. No switch. IP address of 10.0.0.1, 255. And just to check connectivity before we move on. And we are good. So we'll do the same thing on, sorry guys, I'm a little OCD when it comes to this. Okay, that's good. Now let's do this side. What is it? 106 again. No switch. IP address 10.0.1.0. Bad mask. I'm tripping, yeah. I'm gonna do the same up here. What is this? 02. Perfect. IP address 10.0.1. Did I give it? I don't know if I gave it dot. Okay, perfect. And that is it. Let's go ahead and check before we move on. And we are good. So let's go ahead and set up this OSPF area so both switches know how to get to one another. And yeah, let's go ahead and do that. We're gonna do it. What is it? Router OSPF1. We're gonna do a broad OSPF statement to group all. Well, it's not that many. It's only one network, so it doesn't really matter. But we're gonna go ahead and O.O.255.255. It's a broader statement. What am I missing? Network. The network word. 10.0.0.0. We'll do it correct. I'm being lazy. We'll do a broad statement up here so I can group both 10.0.0.0 and 10.0.1.0. That's what we'll do. I will be lazy when it comes to OSPF. Network 10.0.0.0 0.255.255. Perfect. So we only have to do the network command once on our core switch. One area network 10.0.1.0. Okay. After doing that, everything should start appearing shortly. If it's done correct, I'm surprised we don't. There we go. We have adjacencies forming. Everything looks good. Let's see if core switch 1 now has a route back to our VLANs, which it should. No. Do I have to? How do I do it again? I want the VLANs to be advertised, which they aren't because they're not directly connected. Okay, can I do it? I could do it like this, or I could, what you call it? Okay, what I'm gonna do instead of enabling it on the VLANs, I'm gonna just do a broad OSPF statement to group all of our, what you call it, all of our SVIs. Network 192.168.0.0. We're gonna do 0.0.255.255. Area 0. And now the SVIs should be the routes to the SVIs, well, the VLAN should be given to the core switch. We're going to do the same on this side. OSPF. We got to get out of OSPF. We're already in OSPF mode. Perfect. 192.168.0.255. Perfect. Oh, that's not it. We got to add area. Okay, so now our core switch should have routes to our different subnets down here on the access layer. And as you can see, we now have routes. And shortly we should be given 2 paths. As now you can see, we have 2 paths to get down to our access level. So if in case one link goes down, we also have another route there. So now we have redundancy at the distribution layer and also the core layer. So perfect. So we're going to go ahead and do the same thing over here with OSPF. Well, I have to set up the interfaces as well. So let's do that. It's going to be pretty much the same thing. So this is interface. Yeah, same thing. We're also going to change this to gigabit as well, because why not? Top T. What is it? Let me move this. What you guys will be able to see. 6. No switch port. 10.0. Well, IP address 10.0.3.0. 255.255.255.0. Bad mask, of course. We're gonna do 2 down here. Perfect. This is gonna be 1. G01, no switch port. IP address. 10.0.3.1, 255.255.255.0. Let's check the connectivity. Can we ping one another? Perfect. Now we'll do the same on this side. I'm assuming it's the same. Yep. And then we'll be done with this. All right. 4 dots. 1, 255, 255, 255.0. Let's go ahead and ping just to make sure. Perfect. Now let's set up OSPF on this side. So we will be using area 0 for both sides, but it will be like 2 separate area zeros. The reason I say that is because we won't have an adjacency formed right here on the link between the two core switches. So the two offices won't have direct routes to one another. It'll be separate. I just want to keep things separate instead of combining them, and then the routing tables are starting to get confusing and messy. So we're just going to keep it separate. So where we're on distribution, we're going to go ahead and advertise the SVIs and the network they're connected to. 0.0.255.255 area 0. We're also gonna set up that connection with the core switch. I'm gonna do the same up here. But we're gonna do a broad 10.0.0 statement. And catch both sides. Area, oh, I forgot, network. Oh, we're not at OSPF. IP routing, now we can get into OSPF. Uh, 255.255. Area 0, perfect. Last but not least, this distribution layer switch right here, IP routing, router OSPF1 network 192.169.0.0. Area 0, and also the link to the core switch. 0 will, as you can see, those routes, or those adjacencies are coming in 10.4.0. Okay, and that should be it as we wait for those to peer. I'm trying to think what else we need to do. I think we can go ahead and receive. No, we cannot just yet. We need to set up a static route or a default route to make it our way to the DHCP server. So first, let me just make sure those adjacencies are formed. And then we're going to think about how we're going to do this perfect. Okay, so I don't want OSPF to be the reason these two offices can't communicate with each other. I don't know if I'm going to do a default route or static routes. So are static routes advertised into OSPF? So we're gonna do default information originate on the core switch in OSPF. So I think that means static routes as well. So we're gonna do, well, we're gonna do a default route. Oh. Out of to forwarding router's address. That's not the next hop, the forwarding router's address. We're gonna do this right here. I don't know if this needs to be the, what you call it, the next hop, we will see. But yeah, we need to set up this link as well. Now, honestly, I don't feel like setting up another Ether channel, so we're just gonna have one link. You guys get the gist. But we have to set this up. But yeah, I think I'm gonna go ahead and call it for the video, guys. It's actually been a while. So we will make sure our devices receive IP addresses in the next episode. But for now, I think that is it. Well, no, we're gonna finish it. Come on, let's finish it. So now we're just gonna set up the connection between the two core switches. Two dot. Keep it one on this side. Because I'm gonna forget. All right, come on. Thought I heard something, guys. Did I set this up on the right port? Yep. See if we can ping one another. Perfect. So I just want to make sure. Let's set up the default gateway for this right quick. Okay, it's good. Did we set up an IP address already? Okay. Trying to see. Let's see if we have that static route or that default route in here. Okay, so if you have a packet that you want to send somewhere, you send it out 10.0. It will go to this, and this router will send it to 10.0.2.1. And this router right here already has routes to our DHCP server at .99, 192.169.99. So our devices should be able to receive DHCP, DHCP IP addresses via DHCP. Sorry guys, I'm getting sleepy. But yeah, let's go ahead and do the same. Let's set up the static route over here too. We're almost done, guys, I promise. Default information originate. Now we're gonna set up this static route. Default route. The next hop will be 10.0.2.1. And that now should be advertised. So IP route, do show IP route. Okay, so now everybody has a default route on both sides. So let's just see if we can receive IP addresses in the same office first. We'll do it in the CLI. Feel like it's more cinematic. IP config / renew. Let's see if this works, y'all. It failed. Okay. What is the issue? This is where the troubleshooting comes into play. So, oh, did we? We have to set up. We don't have helper addresses configured. I forgot about that. So my first reason for why I think we can't receive DHCP addresses, IP addresses, is because we haven't set up helper addresses on our on our SVIs. So yeah, I'm not gonna lie, we're actually gonna have to call it, and we will get connectivity in our next and final video when it comes to this lab. So I hope you all enjoy, and I'll see you next time.